All right, everybody. Here's a this is one of our test units that's in our test facility that we use for training. We have different units of heat pumps, package units, splits, 70% furnaces, 80% furnaces, and some 90% stuff in here too. But we use this for demonstration a lot. You can see I've got my field piece set hooked up to it, and I'm using the angled quick connects. Very easy to do. I got all my readings. I've got my digital meter already hooked up to it, reading amps and volts and stuff, so we're all set there. This is a G40 furnace. It's a Lennox furnace. I also have my Sling psychrometer, which is giving me my digital psychrometer, which is giving me my enthalpies coming off of it, and I also have another one up there in the supply that's reading the supply air coming out. I also have a manometer hooked up, so I'm taking my total external static pressure at the furnace there, at the coil down here, and as you can see it's running right now 0.47, 0.48, so just under a half an inch, and that was with no filter. Now we're going to put a dirty filter on it. Slide it over. There you go. So now we got a dirty filter, and so the air is just sucking in, and that was a filter we pulled out of somebody's house. Now I'm pulling 0.74 on my static pressure, so static pressure has increased quite a bit. So let's take a look at what we actually have to have, depending on that is. So if you look at this, the 0.5 inches of static, we're running 910 CFM, but at 0.7 we're actually running 770 CFM. So that's the difference between a clean and dirty filter. I'm moving a lot less air, so we'll just pull it off. The unit's been running for about 10 minutes. And we've had a chance for it to pressures to equalize. I'm going to go ahead and turn my tablet back on, and should be hooked up to our readings right now for our system. We'll see what we're getting. This is a 1.5 ton unit, and I plugged in the 910 already. So let me get this so we're not getting the light in it. And so 910, I'm getting 16,000 BTUs out of it. It's a fixed rate orifice, and I'm getting 168 on the suction pressure and 268.7 on the liquid line. We're supposed to have 10.5 degrees superheat, but we're not getting any superheat at all right now. And according to this, I'm not even getting any subcooling. It's not reading subcooling. Let me try turning the gauges on and off, but I'm getting a temperature, so that just tells me that we're not getting our reading out of it's not, the temperature's not enough to show actual subcooling superheat. So let's see if we can get this to pick up a little better, if we can get anything out of it. Nope. So our actual subcooling, I'm sorry, is 8.5, which isn't too bad for this unit. Considered it's a Lennox, they charge by using approach method, and I didn't do the approach method on this one, but I wanted to show the BTUs that I can actually go in and I can get the target BTUs, what actually the unit's pushing out, which is 16,000 currently. The charge on this unit I know needs to be adjusted, and if I look at this right now, we're running a power factor. It kind of bounces back and forth between 0.95 and 1, so I'm going to go ahead and call it 0.95 for our power factor. Then all I need to do is get the voltage. So I get the voltage hertz. We're running white at 120, and then I need to get my amps. And the amp draw on this unit is 5.2. Do the same thing on the other side. Get our amp draw. Again, 5.2, and everything else should be the same on it. So we're going to go over and measure the what the blower and furnace is doing. So take our clamp to it, and I'm going to go ahead and clamp my clamps on there. This allows me to read voltage and hertz real quick. My little Ingasa here. So you'll see this. We'll go ahead and change it to voltage hertz, and we're getting again right at 120. And so then if I want to get the power factor, I click on that. Hopefully it'll give us a good reading on the power factor. We got set for a second. Yeah, 0.49. 0.49, so it's bouncing back and forth. Let's look at our amp draw. Amp draw is 4.1. Let's put that filter back on it, and let's see what the filter does to the amp draw. So you notice the amp draw is dropping. That's because we're cutting off the air, and the blower motor doesn't have to spin as hard. And if we look at our 70.74, so I'm going to change on that iPad, my tablet, I'm going to change the CFMs. Because what did we say it was at 0.70? Let's look at the chart again on our fan chart. 0.74, we're looking at 770. It's actually probably a little less than that, but we'll just go ahead and dial it into 770. 7, and we'll dial it to 70. Okay. Now let's look at what our BTUs drop down. Drop down to 15,000 BTUs that the unit's only producing right now. If we use that airflow, if we have that plug filter on it. So you can see what a change. We lost over 1,000 BTUs easily just because of a plug filter, so the unit's going to cool less. And this is a 1.5 ton. It'd be even more profound if it was a bigger unit. All right, thanks. Oh, by the way, I just want to show real quick how these Kinex work to get them off. So all you have to do is you just take and you just clip on that, and that's it. That's all the refrigerant that comes out of that. No hoses. And then the same thing on the suction side. It just pops right off. A little less pressure on the suction side. And to reattach them, you just push them back in and they clip. So you just got to give them a good solid push and they'll clip right back in place. Really good. If you ever got to get low loss fittings, this is the low loss fitting to have.